Okay, what about the other question? Well, it's also related to us. We were talking about this electrical property. What about our insulators? In fact, in the entire structure of the connector, in addition to electrical protection, it also has a very important one as a shell. They're mechanically operated. Convert keys one by one. We usually talk about, like this hook, secondary locking arm, this male and female match, this kind of mutual maintenance. Keep this kind of locked state. So what about this structural key? In this issue, it actually played one of these. What about our insulators? This plays a very important role. That's our structure. Maintain and cooperate to maintain such a situation. And what about that? It depends on you need to have a certain so-called we call hook design. Or is it? Or elastic structural design. How about this design? The most common one is one. Male and female cooperate. Such a buckle design. What about this buckle design? Applied in our connectors. Very, very much. Both male and female. There is such a thing too. Between this plastic part and the plastic part, there are also cooperation applications. How about this design? One is to stabilize your structure. It's also to stabilize your cooperation. It also plays a role in security. But what about this structure? It's because it's used for this injection molded part. The structure we just talked about. This structure is made of injection molded parts. What about injection molded parts? It has what's called an elasticity problem. What about this elasticity? It will definitely involve what we often talk about, lifespan. What about this lifespan? This metal structure we are talking about. It succumbs to the lifespan of the yield limit. There are some fundamental differences, although its principle is very close. But there are some fundamental differences. Because of our injection molded parts, it's an injection molding process. Our plastic part, it is made of injection molding. During the injection molding process, it is through melted materials, from a rearrangement of molecules to achieve such a shape. And what about the process? It will definitely go through a high temperature. It has to go through a high temperature. Then, because of this project, some plastic, mechanical properties, like this tensile strength, its modulus of elasticity, then this and these. It has this with metal materials. What about the same parameters? Would there be an essential difference? This is a series of differences. So it's on the structure. Structurally speaking, it's about these. This one. What do you mean? Structurally speaking, it is for us the parameter itself. Yes, it is larger. Differentiate one by one. For example, the same person as us. We have the same physical structure. At this location, if I were to calculate this for this elastic card pack, this lifetime, or its fatigue strength, that's for metal. Because the general elasticity of metals will be greater. The modulus of elasticity will be relatively large. So it's this locally yielding space. Relatively speaking, it will be relatively large for plastics. What about during the injection molding process? It's this. The interval will be smaller. Plus it's because it's a high temperature mold. It's a mold. So in the process of forming, it is because of the high temperature of the mold. Because in the process of forming this injection molded part, some temperature, poor reason for it. So it will have an inherent thermal stress. Plus the injection molded parts. What happened when we did this stress analysis? For structural reasons. We all know that. At some sharp corners or some in the process of sharper structure, it also has a mechanical stress concentration problem. So these two questions, for injection molded parts, especially some buckles, for this structure of some elastic parts. It's the two most, very, very critical factors. Does it affect us? Structure life and this structure of this. Elastic fatigue. One of the most critical factors. What about this thermal stress? It's the mold itself. In the process of injection molding, it can't run away one by one impact factor. But what about mechanical stresses? Is that because of our structural design? Some characteristics. Due to some special structural features. Then these 2 points. For our injection molding process, it's implicitly very important data. Are we in our injection molding parameters? Or we can adjust the machine. Can't be visualized. A very crucial place. What about this structure that we were talking about? Its importance for the implementation of our function is very, very critical or very important. How can we guarantee this? Including elastic structures. Including the release of these two yin forces, keep an impact on our accommodation store, at least during our stay. Except we want stability. Except for our temperature change, we also need to ensure our structural design. As much as possible, don't let our mechanical stress focusing on a single point or feature, face,